Traxx, a whole new kind of radio-controlled RC. Fast Traxx. Traxx give you instant traction, fast reaction, climb tougher, break out faster with 11.1 volt turbo power. Fast Traxx really tears. Fast Traxx 360s. Fast Traxx goes where you've never gone before. New 11.1 volt turbo Fast Traxx, also available in blue. You know how you sometimes go and like, oh, this project isn't going to take very long at all? Well, I've finally completed my month-long project. It's just taken me over 2 years. It also wasn't supposed to be this. But let's rewind and figure out how we got here. Oh, and before that, there's an entire blue one that's made entirely of different material, just so that I could film every single step painstakingly, and then edit it, and then voice over it, and then realize my voiceover is the most boring thing in the world. That's in a separate video. All right, this is the third test. The first test didn't have wires for the sensors, and that meant the reverse motor was uncontrollable, basically. Just didn't want to respond very well. That should be locked. After I shut down kind of Commander and doing the sports community, the sports tech stuff for consumer-focused stuff, I was looking for something new. All while I had decided that one of the big problems with these startups that have been trying to do like robot mowers and robot snowblowers is that they keep iterating on a consumer product and then they sell it. And then invariably, people use them, but they use them in the most devastating way. So imagine if you only ever charged your electric car when it was at zero. Yeah, that's how people use mowers and vacuums. These robot mowers and robot vacuums, they just go out and then they die. And then, so they're the harshest on batteries. And then invariably, they come out with their second or their third generation one. And guess what? Well, your first generation one sucks, is completely unsupported, and your battery is a third to a half the price of the original thing. But guess what? They're out of stock because they don't care. And so they're evolving their design. I thought that was stupid because one of the only companies that I've seen with success doing this is in kind of the northeast of the US. And what they did is they built the tech, but they put it in an industrial robot, and then they basically got snow clearing contracts for cities. So I thought, like, I started looking around and surveying, and to build a proof of concept, I decided that I needed not really one of the competitors, but what an industrial piece of equipment. And so there are these remote control, very large robot mowers out of China, and they're all tracked. Boy, that's cool. They'll never get stuck. Not like these little wheelie things. Let's make a small platform to get to work. I started ordering RTK GPSs, like Arduino pilots and microcontrollers and computers and all sorts of stuff to try and get going on just like the basic positioning. How do I figure this out? What's the viability? What do I need before I go looking for like investor money or something like that? So build a small one. Seems like a great idea. Well, it'll take a month to get here. That should be fine. Well, I was banking on 2 because I got started getting busy and the mower showed up in less than 1. Very kind of impressive. Okay, well, I'm not ready. So I keep working on this and I keep getting busy with work. Well, resembles this toy from the 90s called Fast Traxx. And boy, when I was a kid, did I want one of those. But those were what the rich kids could afford, not me. So, yeah, you know, keep working on it. Oh, I need this, I need that. And then I built this, frankly, hideous body, but I tried to make it resemble the original. And it kept breaking. I kept making features, and it was mostly 3D printed. The gearbox was 3D printed. It had real CV output shafts, not these like pins in a slot that move around. No, these actually have balls, and they have a cage. And designing that cage to move exactly half of the swivel angle, that took about 4 books for me to figure that out. I kept trying to reinforce things and redesign things, and bit by bit, it kept getting better and better and better. But it's just an RC track vehicle. And it's cool, but it's also was designed to be this platform, so it's heavy, and I never thought about weight, and I thought about more batteries than I need. And so once I finished it, I was still very unhappy. It looked hideous. It didn't perform very well. I really had to keep the power turned down. It just bothered me. It bothered me so much. So I set about redesigning it for weight reduction, and that was the key. Like how can we reduce weight anywhere? It's kind of where I want now. Like, there are a bunch of little improvements I could make, but realistically, like, I think this is good. This is good enough to go and, you know, be a middle-aged man and go out in front of your house and play with your toy RC car. I'm not embarrassed about that at all. So I 3D printed the whole entire thing again, but in the actual preferred material, which is more expensive, which is PA6GF25, 25% glass fiber. That's where my previous multi-material experience came from. That, frankly, didn't really, like, interesting, but whatever. So the blue one, it's almost entirely reinforced nylon, all the gray parts, but the black parts are just regular nylon 666 blend, because it's cheaper and you don't really need reinforcement everywhere. In fact, about the only places, if you wanted to print this, most of it can be PLA. Things that I would not print in PLA. The whole output system, probably the gears, definitely 100% do not bother printing the gearbox housings out of PLA. They will eventually melt. I mean, especially if you do something weird or push it really hard. It just, the motors get too hot and then they sag. And when they sag just a little, they'll destroy the teeth inside. The gearbox type is completely changed. It was just a spur gear arrangement, 2-stage. This time it is a spur gear with a planetary, and boy, did it get small by comparison. Here's just a little bit of some of my near final testing with the first Fast Traxx 2, which is primarily PLA, except for its output shafts and gears and stuff. How about you? Hey. Oh. So, is there really anything I'd change on this? Yeah, there should be two variants of the tracks for how they're threaded. My ideas of using these pseudo shoulder bolts in the tracks, it seems hit or miss. I think they're trying to back out. So there's two variants, one that threads into the outer side and one that threads into the inner side and uses the shoulder bolt. I would really like to actually replace all of these bolts with flexible nylon band that goes all the way around it. I think it could be done. Why can't I just mold the whole track like the original one? Well, these are involute teeth. They have a profile and they have a touch point, and it's a singular touch point that moves through it as it goes around the gear. So these are actually involute gears. Well, you can't really do that. I tried molding multiple tracks together as one, and it didn't work, and even cutting them just made a mess. I haven't found a better material than this VitaFlex 60. I have tried so many things. I've tried TPUs, various TPUs. I've tried co-printing TPUs directly. I've tried gluing TPU pieces on. I've tried texture TPU for kind of like how this looks. I've tried various things of shoe goo and stuff that people say holds. It doesn't hold. I tried over molding actual silicone I think mold her short A40, which is a little bit softer than this 60. Just rips right off, just completely. And, they say silicone sticks to nothing, but like it was interesting because it felt like it was sticking. There's a textured element here under them that helps it stay on. Didn't really think a lot about where I'm keeping my antennas. Space for wiring sucks. Like I still haven't bothered to fix all the extra wire here. I'd still love to knock another half a kilo out of this thing, but I just can't see it. Tensioning mechanism up front, it could be better. It really could. There's a lot of stress being put on these arms because I canted the suspension back so that like when you run into things, it pushes fore and aft. You can see the tracks loosen. And in the first gen, I had a big beam in between them that made them both go up at the same time. So if the back goes up, it's fine. It drags the front with it. But if the front goes up, it detensions. So thinking about tensioning mechanisms, the only way you can fix this is basically to have like the suspension perfectly horizontal or a link beam in between. But generally it's fine. 360s can lose your tracks. 3MF files are online. I think I've put them up at a few places. Links should be down below. And there will be a link to the video that has me monotonously moaning on and on about insert gear, now add grease. Can't believe it. I tried, guys. I tried. There's almost 7 hours of raw footage that I had to edit to 22 minutes. Check it out at least. It's the best you're going to get from me for a guide. I'd rather make a video than like a step-by-step how-to. I'd love to say how I end most of my videos by saying, I hope you learned something. I don't think we learned anything today, except this could be a fun project if you're willing to spend hundreds of dollars on ESCs, radios, batteries, motors, and overpriced filament. Well, actually the filament's pretty fairly priced. With that, thanks for watching.